We want to solve the trig equation 4 cosine theta plus 2 equals 0 on the interval from 0 to 2 pi. So the first step is to solve this equation for cosine theta. So we'll start by subtracting 2 on both sides of the equation. So we have 4 cosine theta equals negative 2. Now we'll divide both sides by 4. So we have cosine theta equals negative 1/2. So we want to find the angles on this interval that have a cosine function value of negative 1/2. Well, the first thing we should recognize is that since cosine theta is equal to x divided by r, the angles must be in the quadrants where the x-coordinate is negative. Well, the x-coordinate is negative in the second quadrant and the third quadrant. Next, having a cosine function value of negative 1/2 should remind us of the cosine function values that we can find from the unit circle or from reference triangles. And those are the two main methods for solving this type of equation, to use a unit circle or reference triangles. In this video, we'll take a look at both methods. But let's start by looking at the unit circle. So again, our goal is to find angles on the interval from 0 to 2 pi that have a cosine function value of negative 1/2. Well, in the unit circle, the x-coordinate is equal to cosine theta, so we're looking for points that have an x-coordinate of negative 1/2. And again, because it's negative, we know they have to be in the second or third quadrants. Well, notice this point right here has an x-coordinate of negative 1/2. Therefore, cosine theta equals negative 1/2 when theta is equal to 120 degrees or 2 pi over 3 radians. And then in the third quadrant, this point has an x-coordinate of negative 1/2. Therefore, cosine theta equals negative 1/2 when theta is equal to 240 degrees or 4 pi over 3 radians. So these are the two solutions to our equation. Let's also discuss how we can find our solutions using reference triangles. If we ignore the sign here for a moment, having a cosine function value of 1/2 should remind us of a 30, 60, 90 reference triangle, where cosine pi over 3 radians, or cosine 60 degrees, is equal to the ratio of the adjacent side to the hypotenuse, or 1/2. Which means if we sketch a pi over 3 radians, or 60 degree reference angle, in the second and third quadrants, where cosine is negative, we can also find our solutions. So let's go ahead and do that. We'll sketch a pi over 3 radian reference angle in the second quadrant here. And here in the third quadrant. Again, we know they have to be in this quadrant because we know the x-coordinate has to be negative because the cosine function value is negative. Now let's also sketch the reference triangles. And now because these are 30, 60, 90 right triangles, we know we can label the short legs 1, the hypotenuse 2, and the longer legs square root 3. But we also have to check the signs of the legs based upon the quadrants. In quadrant 2, where the x-coordinate is negative and the y-coordinate is positive, this 1 must be negative. And then in the third quadrant, where both the x-coordinate and y-coordinate are negative, notice how the 1 is already negative, but the square root 3 would also be negative. But notice in both reference triangles, the cosine function value would be negative 1/2 here, as well as using this reference triangle, negative 1/2. Which verifies our two solutions are 2 pi over 3 radians, or 120 degrees, which we found here on the unit circle. And the other solution is here, which would be pi plus pi over 3 radians, which would give us 4 pi over 3 radians, or 240 degrees. Again, which we already found on the unit circle. So I think it is beneficial to understand how we can solve these types of trig equations on the unit circle, as well as using reference triangles. I hope you found this helpful.